Hello, welcome back, Math 30-1. So now, today we're going to be looking at leading coefficients other than 1 and how they affect a polynomial function. We're also going to look at how to find the leading coefficient of a polynomial function if we're given a point and some, well, zeros, or the roots and the factors, okay? So before we start off, we're just going to review some points here. Basically, we know already that every polynomial function can be written as a product of its factors and a leading coefficient. So as long as we have all the factors and the leading coefficient, we can multiply them together and find our polynomial function. We also know that every polynomial function has the same number of factors as its degree. Okay? So number of factors is its degree, and the factors may be real, complex, and may be repeated. Okay, so now let's take a look at classroom example number 1. So here we have the graph on the side here, and it says it's of the third degree polynomial function. So p of x is shown. Okay? And we know it goes through the point 2 and 24. Question A states, explain why the equation of the polynomial function can be written in this following form. Well, look at this here. We have 1, 2, 3 different factors, okay, and they're all of degree 1. And if I look at this, all 3 of these factors are a crosser. So all 3 factors are, or all 3 zeros are just crossers. So we know the polynomial is degree 3. Is degree 3, and we also know that the zeros are 0, and we have -1 and 3. Okay? So now it says use the point 2, -4 to determine the value of c. So really, this here is my p of x, or my y function. So I'm going to put -24 is equal to, and this here is going to be my c value, okay? Or sorry, my x value. So I'm going to put in 2 for all my x's. So I'm going to have c, 2, multiplied by 2 plus 1, multiplied by 2 minus 3, okay? So I continue this off. I'm going to end up getting, this is going to be 3. So we get 2c multiplied by 3 multiplied by -1, which gives me -6. c is equal to -24. So here I end up getting c is equal to 4. Okay? So now we're going to figure out what my polynomial function is by plugging 4 back into c. So we know p of x is equal to, my polynomial function of x is equal to, we have 4x, x plus 1, x minus 3. So now I'm going to expand this out. It's in factored form. I'm going to expand that out. So first we're going to leave 4x here. Then we got x plus 1 multiplied by x minus 3 will give me x squared minus 2x minus 3. And then we multiply the 4x into each term, which will give me 4x cubed minus 8x squared minus 12x. Okay? And that is my final solution of what px is in expanded form. Alright, now, let's take a look at question number 2. So here, we're given a graph one more time. It says, the graph represents a polynomial function in the lowest possible degree. So this here is a sneaker, or a point of inflection. So I know this here, the lowest possible degree for this is going to be 3. And this is just a crosser, so that's going to be 1. Okay? So we have multiplicity 3 there, and multiplicity 1 there. So now, it says determine the equation of the polynomial function in factored form. Okay? So we want the equation of the polynomial function in factored form. So first of all, here we're going to go p of x is equal to, well, we know we have whatever c, because we don't know what my leading coefficient is. We're going to multiply that by, now first of all here we have x plus 2. And that is of degree 3. And we have x minus 2 of degree 1. Okay? Now, from using this here, I know what my y-intercept here is. Okay, so if I go, this is counting by 1, 2, 3, 4, 5. So that's going, each of these are counting by 4s. So that's going to be 8. So this is negative 4, negative 8. So my y-intercept is negative 8. So when x is 0, y is going to be negative 8. So we're going to say, here we're going to have negative 8 is equal to c, 0 plus 2 cubed, and then we're going to have 0 minus 2. Okay, so this is going to be c. 2 cubed is going to be multiplied by 8, and then times negative 2, negative 2. Multiply this together, I'm going at negative 16c is equal to negative 8. Continue multiplying, solve for c, so I divide both sides by 16, negative 16, divide by negative 16. I'm going to end up getting c is equal to 1 over 2. So we're going to plug this back in, and it wanted it in factored form. I know p of x is equal to 1 over 2 is my c value, and we're going to have x minus 2 and x plus 2 cubed. Okay? So now let's take a look at class example number 3. It says, determine the equation in factored form of a 4th degree polynomial. So we know a key word here is it's going to be 4th degree polynomial of the function that passes through the point 112 and is tangent to the axis at these 2 points. So if the polynomial is tangent, that's a key word there, at these 2 points, we know these are an even multiplicity. So it's either multiplicity 2, 4, or 6. Okay? But it's 4th degree, and these are the only 2 points where it touches the x-axis. So I'm going to have to know then that both of these are squared. Okay? So we're going to have here now, we have p of x is equal to c. Then we're going to have x minus 2 squared, and we have x plus 3 squared. Okay? And we also know that it passes through this point right here. So now we have my x and y values to find c. So I'm going to plug that in. So this here is px, so I have negative 12 is equal to c. I'm going to have 1 minus 2 squared, and then we're going to have 1 plus 3 squared. Okay? So here we're left with c. 1 subtract 2 is going to give me negative 1 squared is 1. And then we have 1 plus 3 is 4. 4 squared will give me 16. And we have negative 12. So continue that off. I'm going to be left with 16c is equal to negative 12. Divide. I'm going to divide both by 16. And I'm going to be left with 3 over 4 is equal to c. Okay? So we want the equation in factored form, so we don't have to multiply it out into expanded form. So we plug this back in for c in my equation. So we end up having now, we're going to get p of x is equal to negative 3 over 4. And I'm going to have x minus 2 squared, x plus 3 squared. And this is my final answer. Okay. So let's take a look at our 4th example here. We have a 4th degree polynomial passing through the point 1 and 2. And it has zeros at the following. So we know it's 4th degree, and that means we must have at least 4 factors combined. And we have 1, 2, 3, 4. And since there are exactly 4 different factors, we know that all of these are going to be of degree 1. So each of these have a multiplicity of 1. So that makes this pretty simple. So we're going to have p of x is equal to c. and I'm going to have x plus 1. We have x, and then we're going to have 2x minus 3, and we're going to have x minus 2 as all of my possible, these are my roots or factors of the function. Okay, so we also know here that it's going through the point 1 and 2. So we're going to substitute that in. So we know my y value is 2, and we have c 1 plus 1 times 1, 2 times 1 minus 3. Then we're going to have 1 minus 2. Okay? I multiply all these together and simplify. I'm going to get c. And we're going to have 2, 1. 2 times is negative 1. And then here's going to be negative 1. Multiply all those together. I'm going to get 2c is equal to 2. Divide these by 2. So I get c is equal to 1. So if I plug this all in, I'm going to end up getting, I'm just going to rearrange this so I have x first. P of x is equal to x plus 1, since c is only equal to 1. We're going to have 2x minus 3 and x subtract 2. And that's it. Okay? Now let's take a look at class example number 5. So here it says a polynomial equation has the following 3 roots. Okay? So we have 1 here. We have negative 2 as a root of 1 multiplicity. We have 1/3 root of 2 over 3 multiplicity. Okay? So we're going to solve this, and then we have 1 is root of multiplicity of 3. So the graph corresponds to the polynomial function has a y-intercept of 2 over 3. So that's my y-intercept. So when x is 0, that's 0, comma 2 over 3. Okay? Determine the equation of the polynomial function in factored form using the integral factors. Okay. So first of all, we'll look at p of x. Okay? So we have one root, negative 2. So this is the same as x plus 2. Okay? Is equal to 0. Gives us negative 2. So we're going to have x plus 2 is 1 root. Okay? And that is of multiplicity 1, so degree 1. Then we have 1/3. So that's like saying x is equal to 1 over 3. So that's 3x is equal to 1. 3x minus 1 is equal to 0. So we have 3x minus 1. That's another one. And then that's of multiplicity 2. And then 1 is a root, multiplicity 1. Multiplicity 3, so we're going to have x minus 1 to the power of 3. All right, and there's a leading coefficient there. Now, we want to figure out what that leading coefficient is. Well, we know when x is 0, y is 2 over 3. That's when x is 0, so we're going to have c, and we have 0 plus 2, 3 times 0, minus 1 squared, and then we're going to have 0 minus 1 cubed. Okay? Now let's solve this out here. This is going to be 0 plus 2 is c multiplied by 2. 3 times 0 is 0, minus 1 squared is going to be 1. And then we have minus 1 cubed is negative 1. Okay? So here we end up getting 2 over 3 is equal to 2c, negative. Now I divide this, both sides by negative 2, divide this by negative 2, I end up getting c is equal to 1 over 3. Alright, now we're just going to put c back into my equation, so I'm going to end up getting p of x is equal to negative, oh, that's a negative by the way, negative 1 over 3 x plus 2, 3x minus 1 squared, and x minus 1 cubed. And that is my final answer.